PhD of Computer Science in University of Illinois. Dan?
Now, all the things Nan talked about, he's president of the MEF, but he's got a full-time job running his Ethernet exchange. This is my full-time job. I don't have another day job. Nan does. I don't know how he does both of those so well. But because this is our annual kind of anniversary and birthday, it's a chance for us to look back and to set our targets for the next year. So I will finish this presentation with a look forward on what our initiatives are for 2014. So I want to first talk about what open networking means to us. There's a lot of activity in the open space and the technology democratization area, and I want to show in the next two slides sort of how we fit into that. And we talk about the Open Networking Foundation and promoting open networking and open SDN. What does that really mean? And we think it's the definition of the right interfaces that become open and standard. And if you choose them correctly, they don't stifle innovation. They foster innovation, not at them themselves, but above them and below them. We've seen how the Internet protocol did that so well as the narrow waist of the hourglass and a lot of innovation above and below, but we didn't have competing Internet protocols. We had IP. And we're seeing the same phenomenon now in software-defined networking. And I've got sort of three interface areas to bring to your attention. First of all, between the apps and the control plane, we have northbound interfaces. Now, I try to always say that in the plural. We don't think there will be ever one or the northbound interface for a variety of reasons. In the first, there are different uses of the control plane and different versions of the control plane. And let me call out two stark examples. If you're a service provider or a cloud service provider, you want some northbound interfaces that give you control over the elements in your network. But you also want some northbound interfaces to give your tenants control over their virtual resources. Those are pretty different northbound interfaces. So they're probably even at different latitudes of how far north they are. We've done some initial studies of northbound interfaces in ONF, and we created this really wonderful and almost impenetrable chart of latitudes and longitudes that show the different levels of abstraction of the network, each with a different type of northbound interface, and different longitudes of the network for different sorts of use cases and purposes, whether it be having to do with some kind of network control and security, or some orchestration, or some cloud services above. So there's a lot of variety there, but there will be, we think, for most commercial purposes, a fairly small number of popular northbound interfaces. And once they're kind of established, and because they're software, we think they will mostly be established through industry experimentation and not through committee deliberations, then you'll have a lot easier time writing software, creating services inside the control plane, and essentially intermediating between the apps and the control plane. And then, of course, we have the interface between the control plane and the forwarding plane, or the data plane, and that's for remote control of the forwarding plane, and that's where we are creating the OpenFlow protocol standard. So sometimes they're programming interfaces, and sometimes they're protocol interfaces. And we think there's a lot of innovation to be had in the control plane, and a lot to be had in the forwarding plane. I will be talking about that a little bit more. But we don't think there needs to be a lot of innovation in this interface. We're working on the OpenFlow protocol. There are some legacy ones people are getting some mileage out of. Basically, that's not where the industry needs to focus a lot of resources. Let's get that interface down and then do the cool innovation above it and below it. And then finally, down in the forwarding plane, in particular in the hardware switches, we've got switching silicon, and I'll later talk about the great variety there is in those approaches. And they've had proprietary interfaces to their hardware abstraction layer or their SDK. But we are starting to see the emergence of publications of open APIs to their SDK. A fairly major announcement last week from Broadcom, in fact. They were not the first, but they're the most comprehensive so far, and that they're making theirs open source. And there is some evidence to indicate that the chip industry may, at some point in the foreseeable future, arrive at a fairly common API to the hardware abstraction layer. That would be very interesting for the client software and the other things that you need to put into the forwarding plane. So that's a really new development. It started really at the Open Compute Summit in February when Mellanox published their API for the first time, and Broadcom got up and said, we're going to do it soon, and Intel said, we're thinking about it seriously. So watch this space. Now, one important feature of open, which we think needs to not be forgotten, is that open not only means published and may not even only just mean standard, but also means not controlled by a single party. If you want an interface to foster innovation on both sides of it, you can't have it under the control of a party that can change it at a moment's notice and have all those who've invested to interface to it suddenly find that they are outmoded. Consequently, we are advocating for the important open interfaces not to be controlled by a single party, but rather to be controlled by the community. Now, in the larger context of the open movement, open SDN fits in actually quite nicely, and there are many dimensions to this. Some are sort of within open networking and open SDN. But if we start at the top, we've got the open source, and open doesn't always have to be open source. There's a lot of value in open source, but we've got things like OpenStack and CloudStack, and those have turned into really important sort of open source software instantiations of these cloud networking, cloud computing functions, rather, not the networking, the computing part. It's not that they have defined really great interfaces necessarily, because essentially every vendor defines their own plugin, which defines their own interface, but there's a lot of commonality among the ones that are there. But that's a really important trend that we are plugging into. I've also shown the Yetzi NFV. I'll talk more about that. That's not quite the same as a cloud computing stack, but it is an upper layer function that is open and shared among many customers and consequently many vendors. I mentioned the northbound APIs, and those are like industry. That's a factory generated, we hope. We're working on that to make sure that it meets the needs of a wide variety of users. Then we have the controllers, and controllers don't have to be open. There are plenty of proprietary ones out there, but there are some really important open source attempts to write SDN controllers. So certainly you've all heard of Open Daylight. We've been involved with them. Onos from the Open Networking Lab. Floodlight is in widespread use. And then Ryu from NTT in Japan is an open source control, actually they call it an application platform, that a number of our member companies are using really for product development of open flow switches. So these are some great candidates. And then the southbound protocol we discussed. And then down in the infrastructure, we've had not only the emergence of sort of white box and bare metal hardware, but we have now open source hardware through the Open Compute project. The Open Compute Summit was just an eye-opener for me. It was thousands, 3,000 people, and all these interesting designs. Microsoft showed their server rack open architecture with specifications and some implementations. And this is something that we really didn't expect, a few years ago. Now they have augmented their open server architecture with an open networking switch project, and we've been involved in motivating that. And then there are some interesting open source software things happening down in the infrastructure layer, in the data plane. Logopus is it's the name of a bird. It's a project also at NTT. This is an open source a switch client, open source switch that can be either a hardware switch or a software-only switch, where all the switching is done in x86. And then I'm mentioning ONI, the Open Network Install Environment, as a means of getting software loaded onto an Open Compute project switch. And finally, open source optics. This forum was announced at the Optical Fiber Conference last week. And this is essentially an open source controller and some features using OpenFlow 1.4 to talk directly to optical networking elements for use in essentially dark fiber interconnection across the metro region. Now, this is all a number of these open things going on, but there is a gorilla in the room here, and actually maybe it's a penguin in the room, and that's that Linux runs almost everywhere here. The bare metal switches and white box switches, these are running Linux. Certainly all the servers where the control plane and the applications run is based on, a lot of them are based on Linux. Some are based on Windows. Not a lot of other choices. So this has become kind of a de facto really foundation for the development of a lot of these other components. And then finally, I was talking with Stu Bailey, founder and CTO of Infoblox, and he likes to boil things down to the basics. He said, Dan, you know, I think the network of the future is just going to be Ethernet, x86, and OpenFlow. Now, you can have some variations for optical and wireless, but by and large, this could be really what it is. We'll have transmission technology evolving at its own pace. We'll have x86 running control for it and figuring out how to configure it and what it does, and it's just connected via OpenFlow. All this runs under Linux. Let me tell you now what's happened in ONF in the last year. We've had a real surge in growth. We're up to, I believe, I'm never quite sure, 143 member companies. And what's interesting to see is the growth we've had in operators and service providers and in startup companies. We initiated a startup membership category in January of $1,000 a year for companies within 2 years of their incorporation. And we've already got almost 20 of these. Some of them are here today. And in every geography, we've had a lot of growth in the operators and service providers. I would say that the most rapid growth has been in Asia and Asia-Pac. We now have members on every continent except Africa, and affiliates even in South America. And what I am pleased with about this is that we're getting more user and operator requirements driving the work that we are doing. So I also find that this is challenging my travel schedule and my amount of time with my family at home, but it's exciting to meet with so many new and excited operators who want to take advantage of SDN for their new business. Now, our scope in the last year has also increased dramatically, and I've circled a number of things that weren't here a year ago in ONF. I'll talk a little bit more about the Chipmakers Advisory Board, but we got 4 new working groups and 3 new discussion groups. And these are just in response to market demand and our members saying, I want to work on this. We need to do this here. So you've heard yesterday, and you'll hear later today from Justin Dusaday, who's chair of the Migration Working Group. Lyndon Ong chairs the Optical Transport Working Group. And I'll talk a little bit about the wireless and mobile. Northbound interfaces is going gangbusters, trying to define data models and information models to abstract the network services to the applications and abstract the application needs to the network. And then the discussion groups, which aren't yet chartered working groups, so they don't have deliverables in a timeline yet, for security layer 4 to 7 and carrier-grade SDN. I'll talk about a couple of those. The rest of the groups that are not circled are charging ahead, making progress. Yesterday's tutorial run by Mark Cohn is one of the things that our Market Education Committee does. So very briefly, carrier-grade SDN. The carrier said, I want to start this. I want this to drive it. My requirements are a little bit different from Google's and Facebook's. I'm offering paid services, and they're a lot more diverse than some of the web-scale operators are. So, but they're looking at the network and not at the boxes, finally. So it really is the system they're trying to understand to make carrier-grade. And it's a whole new design philosophy, not about design for not failing, but design for the expectation of failure and rapid reconfiguration and flexible use of infrastructure. Now, SLAs aren't always 5 nines. Depending on the service and the customer, they're very different, and they need to be customized to use the infrastructure resources most efficiently for the carrier. You saw the chart Nan showed about cost versus revenues. If they can contain those costs and gather more revenues for the same costs, then they defer that crossover, that dreaded crossover point to way in the future. And increasingly in carrier networks, as well as in the data center networks, there is a move toward commodity parts in the infrastructure, in the transmission part, but custom software that controls it remotely. So these are some of the features that, of course, the carriers are looking for. These are not new criteria, but there will be new ways of meeting these criteria. In wireless and mobile, we've got 3 projects going forward. 2 are service provider oriented, and 1 is enterprise oriented. And you can see we're working on the mobile packet core, wireless backhaul, and enterprise. Not just wireless, but unified management of fixed and wireless services. So working with existing standards like 3GPP, but to enhance mobility management, as it says here, mobile flow steering for offload, and essentially capacity use optimization. Now, wireless backhaul has 2 meanings. It can mean backhaul for wireless networks, and a lot of that backhaul can be fixed, but there's also wireless backhaul. And wherever you have an RF resource, you have a lot more constraints in its operation and its availability. So we're looking to enhance that, because it's a limited resource, with the flexible control that OpenFlow can provide. And in the enterprise, of course, this is just the beginning of a trend where you're going to look for common management and control frameworks for fixed Ethernet, wireless, and optical networks by the network operators. Our layer 4 to 7 discussion group is what it is now. It's headed by Linda was on the program yesterday, I think. And she'll certainly be on the program later. This is where we are trying to meet the needs of the NFV community. If you virtualize these layer 4 to 7 functions, that doesn't mean that the forwarding plane is left out. You can put a lot of the control and the management in a server somewhere in a logically centralized place. But if you need to steer traffic, you're going to need cooperation of the forwarding plane, and that's where SDN comes in. I am pleased to announce that yesterday we signed an MOU with ETSI. This is the top brass in ETSI. It was down at Mondelieu, La Napoule, near Cannes. I was not there for the signing, but this has marked kind of almost a year-long discussion with ETSI NFV and how can we help them succeed, because we're really committed to helping them succeed. And it is our layer 4 to 7 discussion group that is charged with the responsibility of meeting our commitments to ETSI NFV. We had a press release come out yesterday about that. We're very, very happy to see this reach this stage, and we're putting together project teams to make sure we meet our milestones here. So the MOU allows for a lot of areas of cooperation and collaboration, but 3 in particular are actually mentioned, and they are these: the dynamic programmable forwarding graphs for the virtualized network functions, then persistent secure connections among them. This is really traffic steering of the flows to the different virtualized network functions. And then, in general, SDN configuration and control protocols to support NFV. At this point, we don't know how much those need to be augmented from what exists already, but we are prepared to do what is necessary to make the virtualization of these network functions possible and amenable very soon to be put into operation. A lot of NFs benefit from being V'd, and we want to help them do that. And I mentioned the Chipmakers Advisory Board. We formed this last June, and I think we have 18 or 19 chip makers on it, including some system vendors that make their own chips. And there's a battle going on into what the best way is to process packets in silicon. And certainly we've had custom ASICs for a long time. There's been the emergence of merchant silicon, but even that is being challenged by more flexible architectures from network processors and FPGAs. And then there has been an amazing resurgence of doing packet processing in CPUs, x86 or PowerPC or ARM. I mean, I saw one last week. This is that going to be open source software switch that can do WAN gateway functions, MPLS functions, on 4 10-gig Ethernet ports, all in software. Small companies, large companies, it's amazing what you can do. And the cost performance points are different of all these. And sometimes the NPUs stand alone, and sometimes they co-process with the CPUs. There's also the argument of do we do this on NICs, or do we not need NICs, or do we use 10-gig Ethernet inside the data center, or do we use PCI Express? There are new startup companies in chip innovation. I didn't expect this at all 2 years ago, but it is happening. And in line with this is sort of a revolution in packet programming. You've heard of the term, perhaps, protocol oblivious forwarding from Huawei, and they've been showing this, and then protocol independent forwarding and different names for it. And the pipeline compilers, the table typing patterns, the network data path models that we've been working on, and you could almost say were instantiated last week by Broadcom in their data plane abstraction. So this is going to work in conjunction with various kinds of hardware accelerators in the forwarding plane. It's a combination of university research and industrial R&D, and I don't know where it's going to go, but I'm having a good time observing the speed at which it is moving. ONF also has done a lot more in the last year with open source software. We're not, I have to wrap it up. So we're doing open source software. We're generating open source software just to educate the market and to learn about things like northbound interfaces, about our sample tapping app, our OpenFlow driver. We awarded a $50,000 check to CPQD last week, and we'll be prototyping some NBIs. It's important. Software really speaks, and we're learning that language. So our initiatives for 2014 are simple as ABC: to advance open SDN through these means, to build real OpenFlow, and to connect users to SDN. So 2/3 of these are not OpenFlow related. It's still the substrate that we use as a foundation for everything else, but there's a lot more focus on the everything else. There have been some indications of this stuff getting into the mainstream. We don't have time for that today. If you want to be entertained, see me later. And my conclusions are that the evolution is really happening. The operators are speaking out. Some are offering real services. Many are trialing. All of you in the audience who are vendors are certainly responding. The startups are challenging everyone. Our contributions I mentioned. And we find that there is truth in code and in real-world experience, and we are driving hard to get that experience and feed it back into the movement. Thank you for your attention.